Right. Another thing that I wrote about with respect to birds, but I've been thinking about this and can probably apply to other things, is this thing that I call the Himalayan Launchpad. One of the things that I found, particularly with bird distribution, is that there are species which are very, or genera, which have a lot of species, which is Southeast Asian, tropical. And suddenly there's one that's spread across the Palearctic. And I'm thinking, how can this work? How do you get that? And again, it's only one. It's a different kind of exclusivity at a more Palearctic level. How does that work? So the model I suggested is something like this. You have that south to north. Let's imagine that's the Himalayas. That's to the north. That's to the south. So you have in red a population which is tropical, and populations spread and they start moving up slopes and adapt to different climatic belts. So this one is adapting to a climatic belt which blue would represent quite cool. And in this case, latitudinally to the north, you have another latitude belt which climatically is very similar to what you have up in the mountains. So you have now one species and another species, or one population and another population, but they don't meet. But then you get a cold moment. The ones in the mountains come down and the ones to the north head south. And suddenly they are geographically continuous. You then get a warm period. They go up the mountains. They may be slightly different now, but they've been released. And once they're released, they can spread across the Palearctic. The others remain in the mountains. So, what am I saying? What I'm saying is something like this, that once you're up there, and then you're released, what you can do is that. And once you're in that latitude belt, which is equivalent to the altitude belt, you have free territory across another latitude belt, which is to the north. That model repeats itself over and over and over again with birds, and I suggest it might possibly do with mammals as well. I haven't looked at it in so much detail. It's not a one-off. It happens over and over again. But the one that spread there, you might end up with 20, 30 species in Southeast Asia. There's only one. And the one that gets there first wins. One example, the Physedula flycatchers. 14 species Southeast Asia, 9 to the south of the Himalaya, some got across to East Asia, and 4 there. There's a bit of a split there. But again, you can see that by and large, the biodiversity is down here, and the ones that get across, and 4 can probably come down to 2 if you actually lump 3, which are very similar and probably geographical replacements, but we'll leave it there. I don't want to get caught up in detail. But I was amazed when I was looking at this, when I found this paper, 2011, suggesting that the woolly rhino, the expansion of the woolly rhino, has its origins in the Tibetan plateau, and it's exactly the model that I was talking about with birds, and I discovered this afterwards. Now, I don't want to put things in your minds, so I'll just say Denisova. Now, it can work in reverse, because the ones that move up then stay in mountain traps. They're trapped. And you have many examples, like the bluethroat, of species which have boreal distributions today. The bluethroat will reach even into Alaska, from Sweden all the way across. And then there's nothing. And then in the mountains of the mid-latitude belt, in the right altitudinal belt, there are bluethroats. They're trapped. And unless you have another ice age, and they do that, and what you have is the whole range of examples, from species which are very well represented in that mid-latitude belt and altitudinal belts, to species that are missing.